Good evening, ladies and gentlemen. My name is Michael Milde, and I'm the Dean of the Faculty of Arts and Humanities here at Western. And it is my great pleasure to welcome all of you here, so many of you, tonight. A special welcome to our speakers, Professor Naomi Oreskes, joining us from Harvard University, and the CBC's Paul Kennedy, the host of Ideas. They will be introduced properly in just a few minutes. It's wonderful to see so many people coming out to hear our talk on philosophy of science. It just warms the dean's heart, I have to say. Very recently, just at the end of September, the Intergovernmental Panel on Climate Change presented its 5th report. The findings, supported by contributions from more than 250 scientists, confirmed that the climate is indeed changing, getting warmer, and that human activity is responsible for at least some of that change. Without question, this is one of the most serious challenges facing us today, with potentially catastrophic global consequences if we get it wrong. The debate on this subject has been complex and at times strident. It is clear that the actions that have been proposed to combat climate change will have profound social and economic consequences. Inevitably, they will affect entrenched social, economic, and political interests. What is needed in this context is a strong dose of clear and careful thought. Thought that brings together a wide array of perspectives. So it is fitting that tonight's discussion is part of the Rotman Institute of Philosophy's signature speakers series. The Rotman Institute of Philosophy is one of the leading institutes of philosophy of science in the world. Its mission is to bring together philosophers and scientists to discuss and work on the most crucially important questions of the day. The inspiration for this institute came to us from Dr. Joseph Rotman, whose vision continues to support and motivate us in this enterprise. Tonight, it gives me great pleasure to welcome a number of special guests, 2 in particular. First, I am delighted to acknowledge Dr. Joseph Rotman, Western's 21st Chancellor. Dr. Rotman's vision and his philanthropic support of the Rotman Institute has pushed it to become a global leader. We appreciate his guidance and his participation in the life of our community. And I would also like to acknowledge Western's president, Amit Chakma, who is joining us this evening. President Chakma. I will now introduce Carl Heffer, the director of the Rotman Institute, who will guide us through this evening's event. Prior to joining Western in July of this year, Carl was a research fellow at the Autonomous University of Barcelona, and before that, he was at the London School of Economics, where he was director of the Center for Philosophy of Natural and Social Sciences. He is also currently editor-in-chief of the European Journal for the Philosophy of Science. Welcome, Carl.
Thanks very much, Michael, and thank you all for coming. Welcome to Western, and welcome to what is for many of you your first introduction to the Rotman Institute of Philosophy. And tonight's event, which I'm sure you're all wanting to get to hearing about, is going to be Naomi Oreskes talking about her work, which is partly contained in her book, Merchants of Doubt. And our subtitle for tonight, for her talk, is Using History and Philosophy of Science to Understand the Climate Change Debate. And I'm really thrilled to have her here because you will hear actually how philosophy of science can be applied, and history of science, to understanding what's going on in the political and the scientific realm about climate change today. But I'll let Naomi and Paul Kennedy, our other special guest, talk about that in a moment. I'm just going to say a few words about the Rotman Institute itself, since many of you don't know us yet. As you see, our slogan is engaging science, and that is really the best way of saying, in one short phrase, what we're all about. So what does engaging science mean for us? Well, it means connecting with real scientists in their actual work, here at Western and in other places around the world. And we do have philosophers at Western, in the Rotman Institute, actually working in laboratories of scientists here on campus, and we intend to keep increasing that type of activity. It also means exploring complex ethical and policy questions raised by scientific and technological research. And other people at Western and at the Rotman Institute are deeply involved in questions of an ethical and policy-related nature, such as questions raised by new reproductive technologies, questions about clinical trials and how they can be ethically performed in a more efficacious manner, and so forth. And engaging science also means sharing our understanding of science, and especially how and when the claims made by scientists can really be trusted. That's what the general philosophy of science is all about, and Professor Oreskes' talk will actually be giving us a great example of this kind of engaging science tonight. So I'll let Naomi Oreskes' talk speak to that. What I want to do now, before I step down and let them get on with it, is actually show you a bit of our website, which I invite everyone to have a look at when you get back home. So this is our homepage. It's more static here than what you'll see when you get to the real thing, because this is a PDF. But you can see how we're advertising tonight's talk. And on the sort of the second thing that will pop up in the animated homepage, we are launching a new portal right now for engaging the community. And the people at Bridgeable, an Ontario firm, have helped us build tools for connecting ourselves and our work with the public. And I invite everybody to check those tools out, those things we have. They're quite interesting. And the next thing that you would see in the animation is an advertisement for a conference that we're holding tomorrow and the next day. We've brought some of the most prestigious philosophers of science in the world together here, and we're going to have 2 intense days of debate and discussion on philosophy of science, sort of acknowledging my arrival and that of Sestz, our new CRC chair in philosophy of science. But going back to our engagement with the community, when you hover over our webpage, you'll see a drop-down menu, and here there's a link to the public, which can take you to our community portal. And there, what you'll see right now, although we intend to build on it and expand it over the years, right now you can learn about 2 aspects of our work. First, there's a really interesting page on cluster randomized trials and the ethical issues surrounding those, which have been an incredibly important area of work that has been brought to fruition recently in the Rotman Institute. So you click on that and you'll see a wonderful video, and you can take an interactive quiz and so forth. And then you can also click on essentially the magazine that you may be sitting on or may have picked up. And that's another product designed to teach you all a little bit about what philosophers of physics think about at the Rotman Institute. Okay, well, that's enough about us. Now you want to hear what you came for, which is our discussion of the merchants of doubt and the climate change debate. So let me just briefly introduce our speakers tonight. Naomi Oreskes and I go way back. We did graduate school together in Stanford many years ago. She's a very distinguished historian of science and now professor at Harvard University, formerly, until recently, at the University of California, San Diego. She's worked on studies in geophysics and environmental issues and the history of science, and using the history of science and philosophy of science especially to understand, in some cases, still living controversies and what makes them tick. In 2010, she co-authored Merchants of Doubt, which identified really interesting parallels between the climate change debate and some earlier public controversies, like over the effects of tobacco, the health effects of tobacco, and other things. Paul Kennedy is going to be our moderator and sort of the host of the rest of the evening. He's a veteran broadcast journalist and host of the CBC radio program Ideas since 1999. He's an award-winning documentary maker, and he's an intellectual omnivore. If you go to the CBC's webpage for Ideas, you will be astonished at the range of things that he can talk about with great intelligence and lively engagement. He talks about issues in culture and the arts, politics, history, science, technology, and humanities, and so forth. So it's really a wonderful pleasure to welcome Naomi and Paul, who will be leading the rest of the evening. Thanks for coming.
good, except that's my last slide, not my first slide. Although it's kind of a nice preview of what the slide is. So if we can just figure out how to go back to the beginning. There is time travel. We'll start at the end and go backwards. There we go. Excellent. Thank you so much. Well, thank you all so much. It's really a pleasure to be here tonight. A pleasure to see so many old friends and have the opportunity to talk to all of you. So thank you, especially to Carl, for inviting me. I'm a historian of science. I teach in a history department. I've taught for the last 15 years in the history department. But it's really nice to be here because I feel like I'm really a philosopher at heart. Because although I spend time in archives, and I'm one of those strange people who likes dusty old documents, all of my work is really motivated by philosophical questions, epistemological questions, questions about knowledge. And especially, as Carl suggested, the question of the character, nature, the sources and origins of reliable scientific knowledge. And how do we judge? As citizens living in a democracy, we have to make choices. We have to vote on issues that involve scientific knowledge and scientific expertise. And we all know, we all learned in school, that science isn't about appeal to authority. In fact, I was taught in school that the appeal to authority is a fallacy, a logical fallacy. And yet the reality is that we do rely on authority. We do rely on experts. We can't do our own climate science. We can't do our own randomized clinical trials. We have to rely on scientific and medical experts to give us advice on these matters. So how do we judge? How do we know whether or not that knowledge is reliable? And those are the kinds of questions that really have motivated all of the different things that I've worked on over the last 20 years. And it's that question, the question about the reliability of scientific knowledge, that really led me into climate change. Because as we've already heard in the earlier introductions, climate change is a serious issue. It's one that is already affecting the lives of many people here in Canada and around the world. It's affecting the health of Canadian forests, it's affecting the climate, it's affecting the ice in the Arctic, it's affecting biodiversity, it's affecting Inuit culture. So this is a real issue, a live issue. It's not just something in the future, but how do we make sense of it? And how do we make important decisions which hinge on A, whether or not the science is reliable, and B, how significant we think the problem is. So that's what I'm going to talk to you about today. So my talk begins in 1992 when President George H.W. Bush and the leaders of 191 other countries, including Canada, signed the United Nations Framework Convention on Climate Change. And when my president did so, he called on world leaders to translate that written document into concrete action to protect the planet. But as we all know, that concrete action hasn't really happened. Among other things, in 1997, the US Congress rejected the commitment that President George H.W. Bush had made and refused to ratify the Kyoto Protocol to the UN Framework Convention under something called the Byrd-Hagel Resolution, which passed the US Senate unanimously. So the Kyoto Protocol was supposed to put teeth into the UN Framework Convention, commit the United States and other nations to binding cuts in carbon dioxide emissions. The United States rejected that. Canada was a signatory to the Kyoto Protocol, but in 2011 withdrew from Kyoto entirely. Now, other Annex I nations have cut their emissions as they had promised under Kyoto, but not enough to compensate for the rise caused by the rest of the world, including, of course, the United States and Canada. And the US and Canadian contributions are extremely important. They're important not just for what they are in terms of the actual emissions, but also what they led to politically and socially. Because the UN Framework Convention was premised on a phased approach, in which the Annex I nations, that is to say the highly industrialized, wealthy nations, who had industrialized first, specifically the United States, Western Europe, Canada, Australia, and Japan, would be the ones to make the first cuts, because these were the nations that were responsible for the emissions that were already in the atmosphere. If you could put a little flag on every molecule of CO2 that's in the atmosphere, and methane, in 1992, virtually all of those molecules of CO2 would have come from the United States, Canada, Western Europe, Japan, and Australia. So because those were the nations who were responsible for what had already happened, the UN Framework Convention said these are the nations that have to act first. And once they do, then the Framework Convention called for a second phase in which the developing nations like China, India, and Brazil would be brought on board next. But because the Annex I nations did not fulfill their obligations, as you can imagine, China, India, Brazil, and other nations have balked. So it's very popular at the moment to blame China and to point out the rising emissions in China. That, of course, is factually correct, but it's also factually correct that part of the reason China is not part of the Framework Convention is because we never got to step 2 because the United States effectively scuttled step 1. Now, why does this matter? Well, it matters for a number of reasons. As many of you know, global carbon emissions have increased dramatically since the early 1990s. More than 50% total global emissions increase, so we have not achieved even stabilization of emissions, much less cutting them. And with the increase in those emissions of carbon dioxide and methane, we have also seen a direct increase in the amount of CO2 in the atmosphere. This, of course, is the famous Keeling curve, named after my former colleague at UCSD, Dave Keeling. And just a few months ago, the Keeling curve reached 400 parts per million, which is a 40% increase over pre-industrial levels. Why do CO2 emissions and concentrations matter? Well, I think most of you know, because they are directly tied to increases in global average temperatures. This is one of many different diagrams and charts that have been produced by scientists. This particular one shows 4 independent groups around the world who have done analyses of surface global temperatures. So this is a very nice example of the philosophical concept of consilience of evidence for independent scientific groups using different techniques, different data sets, but essentially all coming to the same conclusion that global mean temperatures have risen since the Industrial Revolution just under 1 degree centigrade. And it's a relief to be in Canada because I can talk in metric units. Now, one thing that's very important, scientists talk about mean global temperature, and again, this is surface temperature, so it doesn't include the oceans, which is another matter. Surface temperature is a convenient measurement, it's of course not the only one, and mean temperature is a convenient benchmark. But the reality is that temperature change varies a lot around the world. And that mean temperature change actually masks something which in my opinion is quite a bit more worrisome, which is that the actual temperature increase in any particular place in the globe is different than the mean. And in fact, in places like Canada, it's higher. In fact, over a large swath of the northern hemisphere, it's higher because of the phenomenon known as polar amplification, the way in which ice reflection and ice melting alters the temperature of the Earth. So this is a plot that was produced by my colleague Richard Anthony at the University Center for Atmospheric Research, showing the mean surface temperature anomaly during the period 2001 to 2005 as compared to a baseline from 1951 to 1980. So in other words, how much has the average increased during this period, the early 2000s, compared to a 30-year period before. So during this period, the average increase was ½ degree, but look at Canada. A large swath of Canada had already reached more than 1 degree C warming even in 2005. So Canada and the whole Arctic region is already warming up well in excess of the average, as much as a degree or even a degree and a half in many parts of the northern latitudes. And that, of course, has very significant consequences for ice melting, biodiversity, Inuit culture, and things of that nature. Now, sometimes graphs are confusing, sometimes people get confused or I don't know, confused is probably the best word, by some of the local variability. I can talk more about this in a minute. There's a lot of ups and downs in climate and weather. We all know that local weather is highly variable. So one way I like to look at and think about the weather or the climate change is on a decadal scale, because that's when a lot of the local ups and downs get sort of smoothed out. And this is, to me, a very compelling graphic because it shows you so clearly what has been happening over the globe over the last 50 to 100 years. And we see that on a decade-by-decade basis, a very, very clear signal over the last 50 years. The 2000s were hotter than the 1990s. The 1990s were hotter than the 1980s. The 1980s were hotter than the 1970s. Going back before the 1970s, the signal becomes a little more ambiguous. There's a kind of flat period in the middle century where not too much happened. But interestingly enough, if you look at that whole flat period in the middle, it's warmer than the previous 50 years before that. So if we look at it on a kind of half-century basis, there's absolutely no question that things are getting hotter and hotter and hotter. Just to take one particular year in the United States, 2012 is now the hottest year on record. Now, why does this matter? Why does it matter if it's hot? Lots of people think warmth is good. Lots of people think, I like warm days. I don't like cold. Well, hot is good if you're at the beach. Hot is good if you're on vacation, but it's bad from lots of other perspectives. And one of the reasons that it's extremely bad, that matters a lot in Canada, is forest fires. We are seeing a very clear increase in large forest fires associated with heat waves and droughts. Again, a lot of local ups and downs, but when averaged, when you look at the mean, a clear signal of increased large fires, very significant in the Canadian West, where forestry is an important economic activity, as well as, of course, habitat for biodiversity. Heat is very important also in driving big storms. Hurricanes are driven by warmth, warm surface waters in the areas of hurricane genesis. This is a chart that shows the Atlantic storm season in the region of hurricane generation in the Atlantic Ocean. And one of the really interesting things we're seeing is that the hurricane season is getting bigger. It's getting longer. Hurricanes are starting to be generated earlier in the year than they used to, and they go on longer than they used to. In fact, in many of the last several years, there have been hurricanes being generated after hurricane season was officially over. So that tells you that something is changing. We have this official hurricane season during which hurricanes are expected to occur. Now we're seeing hurricanes both before and after hurricane season. And of course, the importance of hurricanes is also linked to rising seas. There are many different ways that we can measure climate change, but to me one of the most compelling is because the physics of it is so well understood, and also because the variability is less, because the ocean is less variable than the atmosphere, because of basic questions of the heat capacity of water. This is a chart that shows sea level rise since the 1880s, right? So since the period of the Industrial Revolution when fossil fuel use really started to crank up. And here you can see an extremely clear extremely clear signal of rising sea level. And if you look closely, it's not a straight line, it's actually curving upwards. Sea level rise is accelerating. And sea level rise, of course, contributes then to the damage done by things like storm surge during hurricanes and other extreme weather events. Now, fortunately, not too many Atlantic hurricanes reach Canada, but one thing that certainly is relevant is Arctic sea ice loss. You've all heard a lot about the Arctic sea ice loss, so this is a slide that I can use in Canada or in Texas. This compares the amount of sea ice loss in 2013 compared to a baseline of 1981 to 2010. And that's an interesting baseline. I would argue it's actually a bad baseline because by 1981 we were already seeing sea ice loss. We really should do the baseline back to 1950 when the US Navy first started measuring the extent of Arctic sea ice in a systematic way. But nevertheless, so taking this as actual kind of minimum figure, the amount of sea ice loss since this baseline period is the equivalent of 2 of the state of Texas. That's a lot of ice. And of course, the loss of sea ice has many other consequences. Now, everyone I know who works on this issue has their favorite sort of creepy statistic, the thing that's most horrible about climate change, and for me it's this one: poison ivy. Having recently moved to the Northeast from California, scientists have demonstrated that global warming is associated with poison ivy becoming more poisonous. The toxic oils that cause the allergic reaction become more concentrated in poison ivy that grows in an enhanced CO2 environment. So I don't know about you, I think that's really horrible. The next thing they know, they're going to tell us that chocolate isn't tasting as good. Okay, so one other little statistic before we get on to the historical part of the talk. And we also know that global warming is not caused by the sun. Scientists have spent tremendous amounts of time on what they call detection and attribution, understanding both how much climate change is happening and what is driving it. And one of the things we know very clearly, particularly because we have good satellite measurements of it, is that during the last 50 years, the period when we see this very clear warming signal, solar irradiation has actually decreased. So there is simply no way to explain the observed warming by invoking increased heat from the sun. So in short, we can say we know scientifically that warming is occurring. We have extensive evidence of that from many different kinds of data collected by scientists in different laboratories using different methods around the globe and in the field. We know that climate change has costly adverse consequences associated with heat waves, droughts, crop failure, severe weather events, forest fires. We know it's being caused by greenhouse gases, not the sun. And we know it's not caused by the sun. So if we know all these things, if all of these major important scientific questions have been answered to the satisfaction of the expert communities whose job it is to study these questions, our own colleagues in universities like this one, why haven't we collectively, we the world, we Americans, North Americans, why haven't we taken stronger action to control the greenhouse gas emissions that are responsible for all these adverse effects? Or put another way, as a historical question, what happened to the political will that was expressed in the UN Framework Convention on Climate Change to act upon our knowledge, to act upon what we knew? Now, I just want to take a little hiatus here to address one particular kind of interesting denialist claim that's been popular recently, which is the claim that the warming has paused. Many of you have heard this, it's been repeated on the radio and newspapers, the claim that, well, yes, there was some warming, but now it's stopped. Well, this claim is simply false. So how can anybody say with a straight face, how can someone say on television, how can a US senator say, this just happened yesterday, that the warming has paused? Well, the simple answer is they do it by cherry-picking the data. So if you go back to this chart of the mean surface temperature increases, and you look at 1998, you see that 1998 was an exceptionally hot year. In fact, it's now the second hottest year on record. So if you start in 1998 and only look at the part of the graph from 1998 to the present, well, then it does sort of look as if the warming has paused. But of course, you could have done the same thing back in 1960, or 1979, or 90, well, there's several places on the map. And you could in fact have done the same thing and shown, by cherry-picking the data, you could have shown a rapidly accelerating climate change, which is why scientists don't cherry-pick data. Because if you cherry-pick the data, you can use it to argue almost anything. But if you look at all of the data, which is a basic principle of scientific practice, to look at all of your data and not just some of it, then you see that the warming has not paused. Now, I give this particular example because it's not an isolated one. In fact, it's part of a pattern that's been going on for more than 20 years now, that Eric Conway, my colleague, and I documented in our book, Emergence of Doubt. Indeed, around the same time that the scientific community was beginning to conclude that anthropogenic climate change was becoming detectable, in the late 1980s. This is a picture of Jim Hansen testifying in the US Congress. Around the same time that the US Congress was considering passage of the National Energy Policy Act of 1988 to establish a national energy policy to reduce the generation of carbon dioxide and trace gases as quickly as is feasible in order to slow the pace and degree of atmospheric warming. Around the same time that the New York Times declared that the issue of an overheating world has suddenly moved to the forefront of public opinion, and around the same time that the UN Framework Convention was being negotiated and the IPCC was being created, a backlash against the science began to develop. An organized political movement to prevent political action to regulate greenhouse gas emissions. And that political movement was centered on challenging the science, on creating doubt about the reality of the problem, and questioning the scientific experts who were telling us what this problem was. We know that this movement has been very successful. Well after the scientific community told us that it was established by the standards and criterion of scientific expert that climate change was happening and largely driven, not just some of it, but mostly driven by human activities, poll after poll after poll showed that about half of the American people still thought that scientists were arguing. Polls have consistently shown as well that if people think that scientists are arguing, if they think the science is uncertain, then they are unlikely to support action. And of course, this is perfectly logical, because if we're not sure that a problem really exists, then why should we take difficult and expensive steps to remedy it? It makes sense to wait and see if we really don't know for sure. You wouldn't start chemotherapy before your doctor had done the biopsies to tell you that you actually had cancer. So the logic of doubt-mongering is very clear and very sensible. The problem is the result. The aim of the doubt-mongering campaign is to prevent political action by casting doubt upon the science that supports the argument for the need for action. Now, how is this done? Well, I can give a whole other separate lecture telling you about the techniques and strategies, but here I just want to summarize in a nutshell some of the kinds of claims that are made. One of the claims is to say that there's no proof, that the science is uncertain. And of all the claims, this is the one that's probably become most contagious, because I guarantee you that if you start paying attention, and when you read the paper or listen to radio or television, not ideas of course, but you would be amazed about how many times you can hear some person saying, well, I don't know, the science isn't really proven, there's no proof that, fill in the blank. You can find this in many, many places. So no proof is almost a kind of mantra of doubt-mongering in many realms. There's no consensus. Scientists are still arguing, the scientists are divided. If warming is happening, it's just natural variability. That's been a very common claim throughout the history of work on climate science. Some people have claimed even if it's not natural variability, even if it is man-made, it's not necessarily bad. Climate change is good for you. We like warming. CO2 helps plants. Poison ivy. We can adapt to any changes that occur. And this is a common one among politicians. Controlling greenhouse gas emissions will cost jobs, hurt the economy, maybe even wreck it. So for me, this is where history comes into the story, because history can help us understand where these claims come from, who has been making them, and why. And then using history to understand the origins of these claims, we can get a better handle on the question of their credibility and the credibility of the claims that they're trying to challenge. So one of the great things about history is that everything has a start. And when you trace things back to its start, you often find that it's a lot less complicated, a lot smaller when it began than it may have become in later years. And this is clearly the case with climate change denial. In our work, Eric Conway and I were able to trace the source of many of the challenges to climate science back to a think tank in Washington, D.C., founded in 1984, called the George C. Marshall Institute. Now, I don't generally like to refer people to the websites of people who spread disinformation, but sometimes it's useful to know what you're talking about. So if you're interested, you can visit their website. Even today, they continue to argue that the science is uncertain, that there's much of the change is natural variability. The argument shifts depending upon the latest information. Recently, they were pushing this idea that the warming had paused. This was one of my favorite ones, and it's particularly good tonight, because in 2007, they promoted the work of Canadian Timothy Ball, who claims that the idea of global warming, or the so-called fact, which he puts in scare quotes, is the greatest deception in the history of science. So somebody needs to send that man to university to learn about the actual deceptions in the history of science, of which there are plenty. The Marshall Institute has also promoted the idea that the science is unsettled, that we don't really know, that scientists are still arguing that the scientific community is divided. So where did the Marshall Institute come from? And how did doubting science become a political tactic? The Marshall Institute was founded in 1984 by a distinguished scientist, the astrophysicist Robert Jastrow. Jastrow was the head of the Goddard Institute for Space Studies. He was also a very successful science writer who wrote a number of popular books about astronomy and astrophysics, including a rather interesting and famous book called God and the Astronomers, which I recommend to anyone here who's interested in an astrophysicist's argument for finding God in the universe. Jastrow recruited two other colleagues, also physicists, to join him on the board of directors of this new institute that he was setting up. William Nirenberg, a physicist, physical oceanographer who had worked on the Manhattan Project, worked on isotope separation for the building of the atomic bomb, and later became a major figure in US Navy-sponsored physical oceanographic work, mostly related to submarine acoustic detection in the Cold War. And Frederick Seitz, one of the leading solid-state physicist. He had worked with Eugene Wigner. He worked on the hydrogen bomb, and then had become president of the US National Academy of Sciences. So all three were extremely distinguished men, successful, prominent scientists who had worked on important Cold War weapons and rocketry programs and risen to positions of influence and authority because of the work they had done in the Cold War. So why did they found this institute? Well, the original purpose of the Marshall Institute was to defend Ronald Reagan's Strategic Defense Initiative. SDI, sometimes referred to as Star Wars, the idea of building a system to take out incoming intercontinental ballistic missiles, had come under public discussion and public criticism by physicists who argued that it was a bad idea both scientifically and morally. Scientifically, because it was technically dubious, it would cost huge amounts of money and probably be easy to thwart, and diplomatically or politically, because it could potentially be destabilizing, because it would undermine the balance of power in which the Cold War peace had been maintained. And as a result of this, academic physicists began to boycott the program and to sign a pledge saying that they would not accept funding from the Star Wars program. This was historically unprecedented in the entire history of the Cold War. There had never been a wholesale rejection of a scientific technical program on this level. By May 1986, over 6,500 academic scientists had signed a pledge not to take funds from the Missile Defense Research Program. The Reagan administration was extremely upset by this development, and so was Robert Jastrow, who supported SDI. And so he recruited Bill Nierenberg and Fred Seitz to join him in a new institute that would defend SDI by taking the debate out of the halls of science and into the mass media. And he explained that their strategy then would be to write opinion pieces, get on the radio, get on television, talk to editors of newspapers and magazines in order to present the other side of the SDI debate. And to show the American people that scientists were not unified, they claimed, in their opposition to SDI, but that scientists were arguing, that there was no consensus about SDI. Now, the Marshall Institute was never a scientific research institute. These men did not do original scientific research on the topic. They did not attempt to raise funds to support scientific research. They never produced or edited a peer-reviewed scientific journal. The goal was not to produce science, but to challenge it. To challenge the technical and political arguments against SDI. And it was never to do that in the halls of science, but to do it in the mass media. And among the various strategies and tactics they developed, one of the key ones was that if the media did not give them equal time for their views, they would threaten to sue them. They would threaten litigation under the Fairness Doctrine. So the Fairness Doctrine, I don't know if you have an equivalent here in Canada, but it was a law in the United States that said that if you had a radio or television license, because that was considered a public trust, you had an obligation to present both sides of issues of public concern. And for many years, stations were actually obligated to give time to opposing viewpoints. This ironically broke down during the Reagan years because Ronald Reagan opposed the Fairness Doctrine as an unnecessary intervention in the marketplace. But nevertheless, Jastrow and his colleagues used the Fairness Doctrine. So here's one example of how it worked. In 1986, American Public Broadcasting System planned to air a show about the scientific opposition to SDI that featured Carl Sagan and the leaders of the opposition movement. Jastrow considered the program one-sided, and so he sent a letter to every public television station in the United States of America threatening lawsuits if the program were aired. And he wrote, "The program presents only one side of a matter of great national import." He suggested that stations that aired the program, quote, could incur obligations under the Fairness Doctrine to provide airtime for presentation of contrasting viewpoints. What was the result of this threat? He wrote to Bill Nuremberg. Very few public TV programs aired the program. So it had a kind of chilling effect. Rather than face the risk of litigation, the television station simply decided not to air the program. The tactic was so successful that Jastrow boasted to his colleagues that he intended to continue it. Quote, "We intend to continue monitoring the use of public television for presentation of one-sided programs on technical issues affecting national security." In other words, they would pressure the media for equal time, even though, and this of course is a crucial point, their positions were nowhere equally nearly held by members of the relevant scientific community. And there's been a lot of interesting work done on this by communications professor Max Boykoff, who has shown how on many issues, if you look at media coverage, you'll see how the media very often will scrupulously adhere to a kind of equal time or equal space presentation of a controversial issue, even in cases where the scientific community overwhelmingly says, you know, vaccines don't cause autism, for example, or CO2 does cause climate change. Now, most of their work in the first few years was related directly to the Cold War, and arguably related to issues on which they were, in fact, experts. Issues like nuclear winter, seismic verification of nuclear testing, and the future of the space program. But in 1989, the Cold War ended. Now, we might have thought that the Marshall Institute at that point might disband because they might have been happy that the United States, that the West, had won the Cold War. It's not what happened. Instead, the Marshall Institute turned to the issue of global climate change. So this is in 1989, just at that same moment that I talked about, when Jim Hansen is testifying in Congress, the IPCC has just been created, and negotiations for UN Framework Convention are beginning. The Marshall Institute now takes up the question of climate change. And they begin to develop position papers, reports, and press releases, again, not scientific articles in peer-reviewed journals, but reports and position papers, which develop a position that is contrary to what at this point was the emerging mainstream scientific view. So what was their view? Well, in 1989, and then the first version came out in 89, and then a revised version in 1990, they published a report called Global Warming, What Did the Science Tell Us? And in this report, contrary to the emerging consensus of the scientific community, they claimed that there was little or no evidence that warming was either occurring or would be expected to occur any time in the future. Moreover, they argued that even if warming did occur, there was no greenhouse problem because technology would enable us to adapt to any changes that occurred, so long as the government did not interfere in the free market. And for me as a historian doing this research, when I read this report, I thought, oh, well, this is a little bit of an interesting argument because, I mean, there's this sort of beginning to be a little giveaway that this is not just about the science, because here's a group of physicists making what is essentially a political and economic argument. And it continued. In fact, it accelerated. By the in 1992, they wrote a sort of sequel to this report called Scientific Perspectives on the Greenhouse Problem. So at this point now, the UN Framework Convention is being negotiated, or it's being signed. We have scientists beginning to say that they believe this is a significant problem. And in this report, not only do they deny that it is a problem, but they explicitly say that whatever warming may have occurred is caused by the sun. And I don't have time to go into the details, but there's an interesting example of cherry picking where they take a small piece of Jim Hansen's work out of context, a paper in which Jim Hansen and his colleagues were explicitly arguing that the observed warming could not be caused by the sun. But by taking a piece of the graph out of context, they actually made the opposite argument that Hansen made and claimed that the data shows that it is the sun. In the book, we have a detailed description of this incident. And they go on to say that because the free market will solve the problem, there's no need for any kind of international treaty or regulation. Now, in the early 1990s, it looked like they would lose the global warming debate. President Bush did sign the Framework Convention, and the world began to talk about binding cuts on greenhouse gas emissions. But instead of accepting the growing scientific consensus of their colleagues in climate science, in fact, they went the other way, began to amplify the attacks. And as the science began to coalesce, the attacks on the science became harsher, more shrill, and more personal. So in 1995, the IPCC issued its second assessment report, and this was the first time that the scientific community as a whole officially said, yes, we can detect the human fingerprint in the climate system. So up until then, individual scientists had said it. There was quite a bit of literature that said it, but now the IPCC said it as a kind of official pronouncement of the scientific community. And the specific word they said was that the balance of evidence suggests a discernible human impact on global climate. The lead author of the key chapter in the second assessment report, the chapter that looked at the question of fingerprinting or attribution, that's explained how we could tell that the observed changes were in fact caused by greenhouse gases and not the sun or other possible explanations, was a young scientist named Benjamin Santer. Seitz, Nirenberg, and now a fourth physicist who became involved with their work, a man named Fred Singer, launched a highly personal attack on Fred Singer, accusing him of scientific misconduct, effectively accusing him of fraud. In an open letter to the IPCC, which they published in the Wall Street Journal, so again, not in a scientific venue, but in the mass media, and circulated to members of the US Congress, they accused Santer of making unauthorized changes to the IPCC reports, to downplay uncertainties in the science, and they claim make the science seem firmer than it really was. They wrote, they called this op-ed a major deception on global warming, so essentially accusing Santer and his colleagues of lying, and claiming that the effect of these alleged changes was, quote, to deceive policymakers and the public, to try to trick us into thinking that the science was firmer than it really was. Now, Ben Santer, of course, defended his own scientific integrity, and in a long letter to the Wall Street Journal, of which the journal only published about a third of what Ben actually wrote, he explained that, yes, he had made changes, but they were not unauthorized. They were changes in response to the peer-reviewed comments. In other words, he was doing exactly what every good scientist is supposed to do, which is to take account of peer-reviewed criticism, take it under advisement, and make changes in accordance. And not only had he done that, but he had done it in consultation with all of the other authors of the chapter. And all of those authors, in another letter to the Wall Street Journal, corroborated that Santer's account was correct, as did the chairman of the IPCC. And Ben Santer, with 40 other co-authors, wrote a letter to the Wall Street Journal to this effect. Neither Singer nor Seitz ever retracted the charges, which were then repeated by many industry groups and think tanks. And indeed, 2 weeks after Santer's reply was published in the Wall Street Journal, albeit in edited form, the journal gave Fred Singer the last word, allowing him to repeat the claim that Seitz had, quote, revealed that the IPCC report had been tampered with for political reasons. And these charges remain on the internet today. If you Google Ben Santer second assessment report or deception in the greenhouse, you will find these charges repeated today as if they were factually established. And in fact, I sometimes get emails from people telling me that the IPCC can't be trusted because we know for a fact that Ben Santer got to the second assessment report. Now, about 2 years later, so I did an oral history interview with Ben Santer, and he told me a story how about 2 years later he was sitting at his breakfast table reading the morning newspaper about a story about scientists who had participated in a program sponsored by the tobacco industry to discredit the science linking smoking to cancer. And the article explained that the strategy of these scientists working with the tobacco industry was, quote, to keep the controversy alive, to make it seem as if scientists were still arguing about whether tobacco use was dangerous. And Ben said to me that when he read this article, it all sounded eerily familiar. Now, of course, as a historian, when you do an interview, you're not supposed to really talk back to your interviewees. You're supposed to just listen and write it all down. And I turned off the tape recorder and I said, Ben, the reason it sounded familiar is because it was the same people. Because that's what it was. It wasn't just a coincidence that it sounded eerily familiar. Not only were the tactics the same, but the people were the same too. So let's go back for a minute and talk a little bit more about who Fred Seitz was and what he did in the latter part of his career. So as I've already mentioned, he was a distinguished physicist, made major contributions to solid-state physics, served as president of the US National Academy of Sciences, served as president of the Rockefeller University, and these credentials became crucial for what became his last form of paid employment, working as an advisor to the R.J. Reynolds Tobacco Corporation. Between 1975 and 1989, R.J.R. Nabisco, which was the parent company of R.J. Reynolds Tobacco, gave Fred Seitz $45 million. We have deans in the audience, so remember, this is in 1975, $45 million. That would be good money even today, right? I mean, I could do a lot with $45 million. I'm sure our dean here could too. So imagine this, right? $45 million to support a biomedical research program, to support research that casts doubt on the role of tobacco in degenerative diseases. And Fred Seitz was given essentially carte blanche to distribute this money to researchers in any way that he deemed appropriate. The focus was, in his own words, to identify highly promising young investigators who are underfunded at present. So in other words, Seitz went around to universities finding smart, bright, young researchers who were having trouble getting money for their research, or having trouble getting enough money. And interestingly enough, one of them was Stanley Prusiner. How many people here know who Stanley Prusiner was? Right, the man who discovered the role of prions. I find in general when I do research, it's very rare for people to decline to do an interview. Most scientists, in my experience, love their work, want to talk about it, feel underappreciated. So you can usually get scientists to talk, typically at great length, about their work. Stanley Prusiner is the only person who would talk to us for this project. And his secretary said Dr. Prusiner is simply unable to speak about that period of his career. So we can give Seitz credit for identifying smart people, but obviously the difficulties here are pretty clear. Moreover, if we ask the question, well, why did Seitz do this? How did he come to work with the tobacco industry? Again, one of the great things about history is you don't have to speculate because often people explain things themselves. And so in a speech to tobacco industry executives, Seitz explained how he came to work for R.J. Reynolds, and he wrote, "About a year ago, when my period as president of the Rockefeller University was nearing its end, I was asked if I would be willing to serve as advisor to the board of directors of R.J. Reynolds Industry as it developed its program on the support of biomedical research related to degenerative diseases in man, a program that would enlarge upon the work supported through the Consortium of Tobacco Industries." Now this quotation is extremely important because when he refers to the Consortium of Tobacco Industries, does anybody know what that is referring to? So it's referring to an organization known as the Tobacco Institute, which was a kind of umbrella organization under which the tobacco industry funneled the funds that they used for disinformation campaigns, including campaigns targeted at children to persuade people that smoking was fine and good and hip and cool and all those other things. That consortium was part of the basis for the prosecution of the American tobacco industry by the U.S. Department of Justice for racketeering and fraud under the Racketeering and Corrupt Organizations Statute. So he's essentially saying that he was part of what was in fact a criminal conspiracy to commit fraud. He's dead, so I can say that and he can't be prosecuted. And he says, since R.J. Reynolds had provided very generous support to the biomedical work of the university, I was more than glad to accept. So, lessons here for all kinds of people, including university administration, about being careful who you take gifts from. So, now why did the tobacco industry fund biomedical research? Well, of course, they always claimed that this was philanthropy, that the purpose was to support science because they were good corporate citizens. But again, if we look at the tobacco industry documents and we see what they said in private, what we find is that what this was really about was legal defense in court. So Seitz reported to the CEO of Reynolds, Colin Stokes, who explained the goals of this program. He claimed that the charges that tobacco was linked to cancer, hardening of the arteries, and carbon monoxide poisoning were, quote, tenuous. And therefore, in response, Reynolds and other cigarette makers have reacted to these scientifically unproven claims, no proof, by intensifying our funding of objective research into these matters. And again, there you have it. So present academic scientists as somehow biased, but we, the tobacco industry, will fund, quote, objective research. And he continued, science really knows little about the causes or development mechanisms of chronic degenerative diseases. imputed to cigarettes, including lung cancer, emphysema, and cardiovascular disorders. Remember, this is 1979, so this is more than 15 years after the landmark Surgeon General reports, which say that we do know. And he claims that many of the studies are either incomplete or relied on dubious methods or hypotheses and faulty interpretations. And then he explains that the goal of this program then is to create reasonable doubt in court that can be used to prevent having to pay damages in court cases. And so he explains, due to favorable scientific testimony, no plaintiff has ever collected a penny from any tobacco company in lawsuits claiming that smoking causes lung cancer or cardiovascular illness, even though 117 such cases have been brought since 1954. So between 1954 and 1979, the tobacco industry never lost a case, and they won their cases by bringing in scientific experts who they had funded to testify that we didn't really know if tobacco was harmful. Now, happily, this soon would change, and so by the early 1980s, they did begin losing cases, and as part of the discovery process, these documents were released, and this is how we know what the tobacco industry in fact did, because we now have access to these historical records as a consequence of tobacco prosecutions. What we can say now in hindsight is that for more than 30 years, the tobacco industry staved off litigation and strong regulation of tobacco by emphasizing scientific uncertainty. And that is what Seitz and Singer now did with respect to global warming. So by taking the strategies and tactics that he had learned working with R.J. Reynolds Tobacco and now applying it to the problem of climate change. So as I said, this attack on Ben Singer was launched by Seitz Ben Santer was launched by Seitz in conjunction with another physicist, Fred Singer. So let's look a little bit more closely now at Fred Singer as we wrap up this talk. Fred Singer was also a physicist. He also built his career in the heyday of the Cold War. He was one of the early scientists working on the American rocketry programs, became the first director of the U.S. National Weather Satellite Program, and in the 1980s became chief scientist in the Department of Transportation in the Reagan administration in the United States. And in the 1990s, he began working with Frederick Seitz to challenge climate science. Between 1989 and 2003, Singer published at least 35 articles, letters, and op-ed pieces in popular journals and the mass media challenging the scientific evidence of anthropogenic climate change. Many websites and listservers developed on the internet at this time, citing arguments found in his work and that of other individuals affiliated with the Marshall Institute, which then got picked up by venues like talk radio and Fox News. But it wasn't just global warming. Fred Singer also worked in the 1980s to challenge the scientific evidence linking sulfur and nitrogen emissions to acid rain, and he also worked to challenge the scientific evidence linking chlorinated fluorocarbons to ozone depletion. And like Fred Seitz, he also defended tobacco. In 1986, the issue of secondhand smoke came to the forefront as the U.S. Surgeon General issued a report on the health consequences of so-called involuntary smoking. The Surgeon General, reviewing over 6,000 peer-reviewed scientific studies, concluded that involuntary or passive or secondhand smoke is a cause of disease, including lung cancer, in healthy non-smokers, including children. As a result of this work, in 1992, the U.S. Environmental Protection Agency declared secondhand smoke to be a Class A or proven carcinogen, and therefore eligible for regulation under U.S. law. Fred Singer then wrote a report that was funded by the tobacco industry attacking the EPA science. He accused the EPA of violating scientific research standards to justify a political agenda. And here then we begin to see how philosophy of science can help us, because we can ask the question, well, what was this alleged violation? We know something about scientific standards from philosophy of science. Well, the alleged violation was that the EPA used a linear dose-response curve to evaluate the threat. So anyone who knows anything about toxicology knows that a linear dose-response curve is the default assumption in all toxicological research unless you have evidence to suggest a more complex model. In fact, the EPA guidelines, federal law, require the use of a linear dose-response model unless there is scientific evidence to support an alternative interpretation. So what the EPA did was what was legal and what was standard scientific practice under the circumstances. And Singer presented no evidence to suggest that there should have been any other interpretation. Instead, he invoked Paracelsus, who argued that the dose makes the poison, suggesting that at low doses, secondhand smoke would not do any harm. Now, when I first came across this, I thought, this is really great, because Paracelsus, as some of you know, because I hear a few people chuckling, lived from 1493 to 1541. So Fred Singer was invoking 500-year-old science, 500 years out of date, to challenge the EPA. So what do these different debates have in common? Well, one thing they have in common is that in all of these debates, these scientists took positions that were way outside of the mainstream of scientific expertise. The vast majority of scientists had already concluded that air pollution does cause acid rain, that CFCs do deplete the ozone layer, and that secondhand smoke does cause lung cancer. We can say that they were wrong scientifically on every one of these arguments. And yet if we look at the structure of their arguments, we see it was always the same. To claim that the science was uncertain, that the concerns were exaggerated, that technology will solve the problem, and there's no need for the government to do anything. No need for government interference. And so what we began to realize as we looked closely at this story was that this argument, no need for government interference, was really the heart of the story. Not really an argument about the science at all. Not an argument about the scientific methods or the scientific techniques, but an argument about what the government should do about the problem. So why would smart, distinguished scientists attack their own scientific colleagues? Well, many people assume this is a story about money. They assume that Seitz or Singer sold out for money. But we've argued that it's really not that. I mean, money is obviously part of the story, but it's not, in my opinion, the most important part. The most important part is really the political ideology. It's what George Soros has called free market fundamentalism. The idea that if we want to protect our political freedom, we have to maximize economic freedom and minimize government intervention in the marketplace. And I don't have time tonight to talk about kind of the intellectual background of that. There's a lot of, in our book we talk about that in much more detail, but that's sort of the argument in a nutshell. Because in each of these cases, if you ask the question, well, what are these diverse cases, tobacco, acid rain, ozone depletion, global warming, we also have a chapter about work they did on pesticides, what do these things have in common? In each case, the goal of doubt-mongering was to stave off government regulation, to stave off a government intervention in the marketplace to remedy a market failure. And that, I think, helps to explain the origins of this story in SDI, in strategic defense, because after all, what does strategic defense have to do with tobacco? Well, remember that the goal of strategic defense was the same as the goal of all US weapons and rocketry programs, to defend the United States against the Soviet threat and win the Cold War. Jastrow, Seitz, Nuremberg, Singer were all fiercely anti-communist and fiercely opposed to anything that seemed to move the United States in the direction of socialism, which is to say opposed to all kinds of government regulation, control of any kind. And so they argued that government intervention was not required, that technology will develop solutions so long as we leave the marketplace alone. And similarly, the defense of tobacco was for them a defense against government intervention in the marketplace. Because if you recall, in the 1970s, many public health advocates were actually calling for an outright ban on tobacco. But the defense of tobacco was often cast in terms of the rights of free adults in a free society to make their own decisions. A defense of the free market as the foundation of American liberty and prosperity. And so we see this argument cropping up then in many different forms in their arguments. So when Seitz attacked Fanter in the Wall Street Journal, he wrote, IPCC reports are often called the consensus view, but if they lead to carbon taxes and restraints on economic growth, they will have a major and almost certainly destructive impact on the economies of the world. So again, an economic argument, not a scientific one. And when Singer defended secondhand smoke, he said, quote, if we do not carefully delineate the government's role in regulating dangers, there is essentially no limit to how much government can control our lives. And when Frank Luntz, the Republican strategist, attacked climate science before he later converted and then converted back, he wrote, "Once Republicans concede that greenhouse gases must be controlled, it will only be a matter of time before they end up endorsing more economically damaging regulation." So George Soros has called this view market fundamentalism because it's a kind of article of faith, a faith in the ability of markets to solve all problems, and a hostility to government regulation as a form of creeping communism. And indeed, they often refer to environmentalists as watermelons, green on the outside, but red on the inside. And this, we argue, is why global warming became the fight of all fights, because as we all know, energy consumption is at the root of all economic activity. It is at the root of our prosperity. So doing something about energy consumption, the worry was that doing something about it would lead the US to agree to international treaties like Kyoto, which would undermine national sovereignty, and that having won the Cold War, we would lose the peace. And thus, Richard Darman, who was director of the Office of Management and Budget under President George H.W. Bush, who opposed George Bush's signing of the UN Framework Convention on Climate Change, said, "Americans did not fight and win the wars of the 20th century to make the world safe for green vegetables." Now, the American Barry Goldwater once famously said that extremism in the defense of liberty is no vice. But I think this story shows that it is indeed a vice, and in fact, extremism of almost all forms is a vice. Because these men may have been perfectly justified in their political beliefs, and it is right to ask questions about what the justification for government intervention or government regulation is. And it is legitimate, in my view, to say that if we're going to make major changes in our economic system or have a substantial tax on the use of energy, that our arguments for doing so ought to be awfully robust. But they didn't make a political argument on political grounds. Instead, they camouflaged a political debate as a scientific one. And as historians and philosophers of science, we can look at this and say, this was not a scientific debate. And in the process of doing that, in the process of pretending this was a scientific debate, when in reality it was a political one, they misrepresented the science, they confused the American people, and they delayed political action on one of the pressing global issues of our time. In the 1980s, global warming was still a prediction, and many people of different political stripes argued that we could afford to wait and see. Now, 20, 25 years later, 30 years later, we have waited, and we have seen. The predictions that scientists made in the 1970s and 80s have come true. Global warming is here, and there are almost no communists left. Thank you very much.
Let me begin by thanking Naomi for a very erudite and, I would say, scientific, historical argument that came to the conclusion that we probably all should have come to 35 years ago. And unfortunately, we didn't. I guess the first question, and what we'll do now, I will ask a few questions, and then we'll give the opportunity for everyone in the audience to ask questions. We're limited in time, but we will have time after that. There will be a reception in which private conversations could perhaps take place too. So that's the sort of game plan for the rest of the evening. My first question is that since science was attacked on a political front by an organized lobby based in this one group of 3 people, basically then 4 people, and was successful in some ways in really dumbing down the political debate as well as the scientific case that was being made. Your book has been a very well-argued, well-researched study of that process and that period in history. Has your book been subject to the same kind of attack?
Oh, of course. I mean, you know, one of the things that was strange and slightly surrealistic about doing this work is as we're reading about the strategies and tactics, I mean, I was already being attacked because I was already starting to speak in public about the issue, and I published a few articles. So I started to see those strategies and tactics being used against myself. And that was a little bit of a strange place to be in, because then I was like, I was at risk of becoming a character in my own book. And so at one point, Eric Conway and I actually talked about that. He said, well, should we talk about that? And we decided not to, because we didn't want to be characters in our own book. We thought that was a little too postmodern, you know. So we didn't go there. But in a way, in a weird way, it was helpful, because it also helped us know that we weren't misinterpreting what was happening. And every time we would get, you know, I mean, part of the story was I started getting these emails accusing me of being a Stalinist. And I thought, wow, how do you go from explaining climate science and sort of talking about climate science to being a Stalinist? That seemed like a very large intellectual jump. And so, you know, so part of the challenge of this was to try to understand what was the sequence of logical steps, you know, that gets a man like Fred Seitz from, you know, working on SDI and being worried about the communist threat to thinking that environmentalists are watermelons.
It's also fascinating, as you point out, to the connection between the tobacco industry and their arguments, and then later what seems to be a completely separate universe altogether. But when you actually do the historical work, you find that the personalities are exactly the same people. And it's astounding that they, in some sense, got away with it.
Right, and in a way that was for us, I guess you could say, the exciting part of the research. That was the point, I think, at which we realized we had to write a book. In fact, I even remember that day, because this project started because I had done some work on climate science. I was starting to get attacked, and I was at a conference, a pretty academic conference, the International Commission on the History of Meteorology. So, you know, not like one of your big marquee academic conferences. And I was talking about the work of an early climate scientist, Gordon MacDonald, but somehow in the Q&A it came up about being attacked. And I said, yeah, it's sort of like a little weird, I'm not really sure what's going on here. And then after my talk, Eric Conway came up to me, we hadn't met before, and he said, Naomi, you know, the people who are attacking you are the same people who attacked Sherry Rowland about the ozone hole. So I don't know if you know, but Sherry Rowland was one of the key chemists who worked out the chemical mechanisms by which ozone is depleted by CFCs, and he shared the Nobel Prize in Chemistry for that work. So this is one of the greatest, most important, significant scientists of the 20th century. And at first I thought, what? Like, the same people who attacked Sherry Rowland are attacking me? And then I thought, wow, the same people who attacked So we started talking, and Eric had done a lot of work on the history of ozone depletion because he's the historian of the Jet Propulsion Laboratory. NASA did the key work on the atmospheric measurement of ozone depletion. So Eric knew a lot about that history, and he had never written about the attacks on Sherry because it just seemed like this weird thing that wasn't, you know, he was writing about NASA-funded science, and he was trying to understand the science, and he's a historian of technology by training, so he's really interested in the instrument. Is this like too loud? Because it's suddenly, no, it's okay. It's suddenly loud for me when I turn my head. You know, he was really interested in the platforms, the instrumentation, the satellites, the launching pads, all this technical, you know, good geek stuff. So he hadn't really pursued the political piece. And so we started just digging into it a little bit, and then I sort of, you know, found that it wasn't just ozone, it was also acid rain. And then I found Seitz's connection to the tobacco industry, and I called Eric up. I said, Eric, we have to write a book. You know, because at that moment I realized, okay, you know, it's like one of those children's puzzles, which of these things doesn't belong? Because, you know, ozone, acid rain, climate change, well, they're all about the atmosphere at least. So, and many of the scientists who worked on ozone did in fact later work on climate change, so there was a kind of logical connection there. And even though the science is different, you know, there's some overlap in the domains of expertise, but tobacco, I mean, obviously, that was something totally different. And so that connection to the tobacco industry, you know, made it clear that there was something going on that wasn't just scientific. And so then I called a colleague of mine, Robert Proctor, who's done extensive work on the history of the tobacco industry. And again, one of these relatively honest, you know, sort of innocent questions, I said, Robert, have you ever heard of a guy named Fred Seitz? And he goes, have I heard of Fred Seitz? The next day I've got, you know, 25 PDFs in my inbox of documents that Robert had. He had never really pursued Seitz because he was, you know, it's a very big history. So then that, you know, one thing led to another.
Most of the work that you talked about tonight is work that was done on what happened in the United States.
Right.
I want to know whether you can tell a similar story, or if there's a similar story to say about Canada. And after that, I guess another question is, how isolated is North America, perhaps adding Western Europe and Japan and Australia? How is the science here attacked in the same way as it's attacked in other countries? In China, Brazil, the next group you were talking about, where does it all fit? What are the similarities, what are the differences go around the globe?
Yeah, well, of course, it's a U.S. story because we sort of fell upon the story. We stumbled upon it, and then we realized that it's a story to be told. And also because we were interested in the question of why the U.S. had backed off its commitment to the Framework Convention, which at that time, the United States was really out on a limb, and at that time the United States was the only Annex I nation that was refusing to sign on to Kyoto. So it did seem like a particularly U.S. story. One of the things that's sad about this story is that it became a kind of contagion. It spread, and it spread outward, and as you know, it spread to Canada. And so, Canada's reversal on Kyoto, the recent activities of the Harper government, in my opinion, are pretty upsetting. And we certainly have seen in Canada, as I know you know, serious attacks on science, serious attempts to muffle science. You probably know about Andrew Weaver, who's filing a lawsuit against one of your newspapers for defamation. So it's definitely spread. It hasn't had the same kind of traction in Europe, and I get asked about that a lot. And I think one thing that's really different in Europe is, in the United States, just calling somebody a communist is enough to make people crazy. Whereas in Europe, lots of people say, I'm a communist. We have, in Europe, there are communist parties. In France, communists hold seats in parliament, and certainly there are credible socialist parties all over Europe. So just the sort of taint of socialism doesn't have the same cultural or political resonance that it has in the United States. So I think that whole line of argument that Kyoto is a slippery slope to socialism doesn't really do much political work in Europe. And then Europeans, of course, in general, are more sympathetic to centralized government. Certainly in France, I spent a fair amount of time in France last year because the French edition of the book came out. And there is a little bit of a denialist movement in France, but it has a totally different character there. In France, French people, to make a gross overgeneralization, but in general, the French, I would say, are more cultural with intellectual elites than people in the United States are, and they're more respectful of scientific authority and other forms of authority. So just the idea of attacking science per se doesn't get that much traction. So in France, there are a couple of prominent climate change deniers. I see them it's much more individualistic. They're sort of cranky people who are irritated at their colleagues, for one reason or another. And there's this one fellow, Vincent Corio, who's a geophysicist, who also took a strong contrarian stance over the KT boundary debate about what killed the dinosaurs. So I think he's one of these people who just sort of really enjoys being a contrarian, enjoys having a good argument, enjoys the attention. Because, there's also an attention factor here. If you're a, medium-level scientist with some credibility but not winning a Nobel Prize, if you just say, yeah, I agree, my colleagues are right about climate change, you don't get invited to be on television. But if you say, oh, I disagree completely, I think my colleagues have made a grave error here, suddenly, you're on the front page of Le Monde, and you're on, TV5 or whatever it is. So, there's a way you can get a lot of personal attention. And so I think in France, you see a little bit of that going on. And then Germany is, yet another example. Again, there's not a big climate change denial movement in Germany. Angela Merkel has been on board about this, one of her closest advisors is a top climate scientist, but there is a bit of a denial movement funded by the German coal industry. And that's getting a little bit of a resurgence now because of the whole anxiety about nuclear power related to Fukushima. So there's been a kind of, the Germans have gone back and forth on this issue of the role of nuclear power, and so that's created a little opening for some people to, try to question climate science yet again. But it's much, much less, and it doesn't have the same cultural character that it has in the United States.
It does pose another question, though, and in your talk you sort of mentioned that it's not over yet. It's not over yet.
Right.
Your talk was a lucid description of the history, and it, has good guys and bad guys in the book. it isn't over. I mean, people are, yesterday, today, whatever, still deniers.
Right.
And they still get an audience. I mean,
Yeah.
so it's not only a history, you can project into the future pretty well what the kinds of movements and discussions and arguments you were talking about.
Right, and there's sort of a companion book that someone should write, but it won't be me. But you know, why did so many people accept this? Because in a way, I think of this as a supply side book. We're really telling a story of people who supply denialist arguments, and we really, the story doesn't really account for why people accepted it and why they gained so much traction. And that's really a different kind of story to be told. And you know, we could speculate on some of the reasons, but we didn't do that work. But it's important to look at and to think about, you know, why are these arguments so persuasive to people? And I think, you know, I think some of the answers are pretty obvious. We like the way we live. We don't really want to change it, especially here in Canada. You guys are sitting on some pretty amazing fossil fuel resources that the world is interested in buying. So to say, no, we're going to walk away from that and leave those resources in the ground, that would be a very, very, you know, bold thing to do. And I'm not even necessarily saying that is what needs to be done. I mean, my own personal view is that Canada should be leading, this is for the president to pay attention to, I mean, I think Canada should be leading in research on carbon capture and storage, because you are sitting on tremendous reserves of fossil fuels that are worth billions or trillions of dollars, and if we could work out a workable mechanism of carbon capture and storage, then a lot of those resources, in my opinion, could be used without damage or without excessive damage. That's not happening yet, but there's no reason to think that that couldn't happen.
That's a hopeful way of looking at it. I wonder, though, if you were to write this next new book and include a chapter on Canada or something, if we wouldn't be slightly different from the American story you've got. And not different, I'm not trying to make Canada sound like the good guy in any way here, but I think that the argument would be made, or the historical trajectory that you describe in the book would be slightly different in Canada. You say it's a political argument, not a scientific argument. In Canada, because of this enormous reserves of carbon, fossil fuels, it's an economic argument, not a scientific argument. Right. And I think that's the way it is being presented and defended in Canada is through an economic argument.
Well, ultimately, it is an economic argument, because ultimately this is about how we run our economy, which is based on tapping the energy of fossil fuels. So it's obviously an economic argument in the United States as well. But I think from the point of view of this particular group of people and why, you know, the question we started was, why would someone like Fred Seitz make common cause with the tobacco industry? I think the answer there is ideological and political, right? I mean, Fred Seitz did not have, you know, major holdings in the tobacco industry, right? He wasn't personally very deeply financially invested in tobacco, although he, you know, may have had shares. But he was very vested in the idea of American freedom and the idea that the government should not tell us what to do and that the government should not be interfering in the marketplace. And so that's a kind of political and ideological argument that resonates with a lot of American people. Remember, you know, we're the people who think the government that governs best governs least, right? And we have a gigantic, long history of suspicion about powerful centralized government. So, and that precedes the Cold War. The Cold War became a kind of manifestation and expression of it. So that plays a big role in the kind of political characterization of the problem in the United States. But of course, it's also hugely economic, right? And the United States is not sitting on the same kind of fossil fuel resources that Canada is, but we certainly have very large fossil fuel corporations that have a very significant interest in this issue. And of course, you know, I didn't talk tonight about who funded all this, of course, and that's a whole other story. But one of the things that we know is that the early years of the Marshall Institute, they were mainly not funded by the fossil fuel industry. They may come in cause with the fossil fuel industry later as they became more and more involved in the climate change issue. So we know that major fossil fuel corporations have funded the Marshall Institute a lot in the last 10 to 15 years, as well as a whole host of different think tanks that have also spread, whatever you want to call it. I call it disinformation, but challenges to climate science. The Royal Society in the United Kingdom did a study, analyzed ExxonMobil's philanthropic contributions and identified 32 different organizations funded by ExxonMobil that spread disinformation or misleading information about climate science. And that's pretty depressing, you know, especially if you'd like to believe you know, if you don't want to demonize the private sector, and you'd like to believe that responsible people in the oil and gas industry and the coal industry don't want to destroy the world, you know, and don't want to cause undue pain and suffering. But when you see evidence like that, it's a little bit, it's pretty distressing, you know.
I'll ask one more question.
Yeah,
and
sure.
then we'll open for questions to the floor. I think there is a microphone that can be moved around. And so I guess put your hand up if you have a question. I'll ask one more question before we do that, though. And it's deeply personally reflective, I guess, and that is, you alluded briefly to the role of the journalistic world in this whole story. And I guess the question, simply put, would be to what extent do you think that was collusion, or was it ignorance, or was it just irresponsibility? That journalists are not doing their job.
All of the above.
All of the above. Guilty as charged.
You know, it's really funny because my editor really wanted us to slam journalists. My editor thought, the initial version said almost nothing about journalism, and then my editor came back and said, look, you have to say something about journalism because, you know, you've said that a whole part of the strategy is to target journalists and pressure them for balance, so, you know, you have to finish that sentence. So we did that a bit, but then I said to the editor, yeah, but we want journalists to review this book, and we want to be invited to talk about it on television and radio. And the funny thing about it was, so, you know, there's a little bit of a book about that. And I think it's all of the above. I do think that some journalists were just ignorant. And that's fair enough, because let's face it, if you're a political journalist or an all-purpose journalist, you know, you don't really know what the state of the scientific debate is. And they're tapping into the journalistic idea of balance and objectivity. So it seems appropriate and reasonable for objective journalists to give time to both sides of the issue. So some of it is ignorance. Some of it is manipulation. I mean, these guys were very savvy about the media, and I didn't have time to talk about it, but the tobacco industry were absolute masters of this. And for me, actually, the most depressing part of the book was the part where we found documents speaking to how the tobacco industry would arrange meetings with leading journalists, with editors of newspapers and magazines, and say, you know, call Arthur Oak Sulzberger of the New York Times and say, can we just drop by and chat with you for about an hour on some research that our scientists have done about the question of tobacco? And the editors would invite them, and then they would present this research that they had done, although in most cases it wasn't really research, or it was highly selective, it was cherry-picked, to show, to convince the editors that the science was still unsettled. It is amazing how many editors fell for that. And for me, like the tragic moment in my book was the story we told about Edward R. Murrow. And I'm reading this material, I'm thinking, A2? It's like, how can this be Edward R. Murrow, right? The greatest journalist of the 20th century fell for this lock, stock, and barrel. And there's this amazing note where the tobacco guy who met with him says, Murrow totally understood our argument, and he and Fred Friendly, who was his producer, are going to do a balanced section on the tobacco problem. So a lot of people fell for it. But so in the book, we kind of cast it mostly as journalists being ignorant. Stan Glantz, who's done a lot of work on the history of tobacco, calls me up and he goes, Naomi, you were way too easy on these guys. He goes, ADVERTISING. Right, I mean, the tobacco industry did spend huge amounts of money on advertising, and certainly the worry that you could lose advertising could well have played a role in many people's thinking. We didn't really have evidence about that, but of course, you'd have to look in a different place to find out. You know, you'd have to do a kind of history of the journalistic side of it to try to figure out how editors did, in fact, think about that question.
Sounds to me like there's lots more books.
There's lots more work to be done.
Yeah, for sure.
Yeah.
Questions from the audience? One back there. And just as the mic gets there, can I point out, this is not the, this is actually called the question period, so we're not looking for slightly shorter speeches masquerading as questions. Perhaps proceed the questions with a brief preamble, but get to the question as quickly as possible, which give others.
And I'll try to get to the answers as quickly as possible.
Question as a question, if that's okay. One of the slides that you put up
Could you stand up so I can see
sure.
who I'm speaking with? Oh, thank you.
Yeah, one of the overheads that you put up was a letter from Jastrow, I believe, and it seemed to refer to him applying to register the Marshall Institute as a 401c not-for-profit group. And I've done this myself for cultural organizations. I mean, my understanding of that classification is that you have to serve the public interests. You have to make all your accounts open to public scrutiny. Is the Marshall Institute a 401c foundation, and has it in fact fulfilled its obligations under U.S. law?
It's a great question. So legally, under U.S. law, they are 401c. I think it's a really good question, and I think if there are any young lawyers in this audience interested in pursuing this question, it's my personal opinion, I'm not a lawyer, but it's certainly my personal opinion that the Marshall Institute and many groups like it seem, at least on the face of it, to have crossed that line. So it is a very interesting question whether or not they may have broken U.S. law.
The force of your presentation is that these scientists were involved in sort of from a certain perspective politically. I wonder whether you've had any interaction with Dr. Freeman Dyson, who also opposes or is this climate change skeptic, and I wonder if you can impute any motivation to him other than he's a physicist, obviously.
Yeah, there's that part of it. We were talking about Freeman Dyson at lunch today, yeah. So I've had a little bit of interactions with him. So I should make clear, as far as I know, Dyson was not part of any of these activities. We never found any evidence that he was part of this. What's peculiar to me about Freeman Dyson is that he actually switched his position on climate change. Because in the 1970s, he was actually quite interested in the problem and concerned about it. And one of the first U.S. government reports that was done on the issue was a report by the Jason Committee, which is a highly influential and somewhat secretive organization of U.S. physicists who advise the U.S. government on a variety of issues. In 1979, the Jason Committee did a big report on climate change in which they said, in a different version of this talk, I talk about them, that they thought climate change would be a problem. They made some of the early forecasts of what the climate sensitivity was, and they even specifically said that climate change was a real worry because of the sensitivity of food production to small changes in weather and climate. And they pointed to the Sahelian drought as an example of how small changes could have big impacts that kind of ramified throughout the world. Also the Soviet grain harvest failures of the 1970s. In the introduction to that report, they thanked Freeman Dyson for helping to call attention to this issue and also for reviewing the report. So we know that in the 70s, Dyson actually thought climate change was an important problem, and somewhere along the line he switched his views. So I actually contacted him a few years ago and I asked him about it, and I said, well, what made you change your mind? And he just wrote back and said, I don't believe the climate models. And I have to say that argument makes no sense to me because the climate models are only one small part of the puzzle. And in fact, some of us were talking earlier about another paper that I've written, and actually Dyson's comments informed that article that we were talking about, because I have a section about the climate models in which I argue that although climate models are useful and important in many ways, you don't need a climate model to know that there's climate change. And in fact, the early predictions of climate change that were made by people like Roger Revelle and Bert Bohlin in the 1950s, those predictions were made before anybody had ever built a climate model. So even if you throw out the climate models, we still have a very, very large amount of data that tell us that climate change is underway, and we still have very, very robust basic physics telling us that if you increase the amount of greenhouse gases in the atmosphere, you expect the planet to warm. So I have to say that Dyson's argument doesn't make sense to me intellectually, but I don't know him well enough to have an explanation of why, what other argument he would have.
More questions?
Thanks. Actually, I have a quick follow-up on your last remark. I don't think climate models. I guess it depends on what kind of model, right? I mean, you need a zero-dimensional energy balance model to say anything. And then presumably you also need to know something about feedbacks, right? I mean, if the negative feedbacks were strong enough. So it's unclear to me. I mean, you need some models to say something. Maybe you need the simple models.
Yeah, right. I mean, obviously, like I said, models play an important role, and we could have a long discussion about models, and there's good people here in the audience interested in this issue, and I'm really, really interested in the role of models in climate science and in science in general. Certainly the models have played a very big role in how scientists have dealt with some of the attribution issues, and in particularly Jim Hansen's work, in which he tries to unpack what is the contribution of solar irradiance, what is the contribution of volcanic aerosols, what is the contribution of greenhouse gases. Models play a really, really big role in that kind of analysis. But nevertheless, the fact is people did predict climate change based on, the simple sort of zero-dimensional model. I mean, you could just say it's equations. People predicted that climate change would happen, and now we have a great deal of empirical evidence that that climate change is occurring that does not depend upon general circulation models. So the basic argument, we expect climate change to happen, we see it happening, as sort of basic, hypothetical deductive model of science. That basic argument stands without any climate models. Do the models help amplify the argument? Absolutely, they certainly do. Is the argument weaker without them? Yes, it is weaker, but it doesn't rest solely or even primarily on the climate models. I mean, I do think, my own personal opinion is that the climate science community has actually overemphasized the importance and significance of modeling, and then that's a whole other question about why the climate scientific community has done that. But yeah, that's a different question.
We have time maybe for 2 more questions. I think, I know you all want to go listen to ideas tonight, and that starts at 9 o'clock, but also I want to emphasize again, there will be a chance at a reception to ask other questions privately. So, penultimate question. Great.
I wonder if you see a connection between the stories you've told about tobacco and climate change and the controversy about creationism and intelligent design.
Yeah, absolutely. I get that question all the time. And the fact is there are a number of links. And at one point, our editor asked us if we were going to write about that. And we had 2 reactions. One is, it's bad enough having the wrath of the whole climate change denial community. Now we have the wrath of the entire Christian evangelical movement as well. That sounds pretty dangerous. And also we said, do you want a book or do you want an encyclopedia? So there's a lot that could be said about that. The short version of the answer is, there's a kind of interesting politics make extreme bedfellow aspect of the story, because when these folks started out, they were not at all involved with religious people. And actually, Seitz, Nuremberg, and Jastrow had rather different religious views. I knew Bill Nuremberg moderately well. He was the director of Scripps. He had just recently retired when I went there. He was an atheist. He was pretty anti-religious. He really had no time for evangelicals or fundamentalists of any type. Bob Jastrow was very different. Bob Jastrow believed in the argument from design, and he believed that you do, in fact, see evidence of God's work in the heavens. Sort of a kind of the heavens are telling the glory of God. And he wrote very, very eloquently on that point. And so he's a very interesting thinker because he's pro-religious, but he's not Christian. He was actually Jewish, so he's a kind of, and he was an old earth creationist. So he does believe that the heavens and earth were created by God in the conventional sense, but he's not a young earth creationist. He believes that the universe is 4.5 billion years old. And he believed very strongly that the Big Bang is the moment of creation as told in the story of Genesis. So he connected scientific discovery with, so he's a kind of reconciliationist. So he's actually a very interesting thinker. But one of the things that happens in the story is that later on, cruder, less interesting forms of creationists, young earth creationists, take up Jastrow's work and they make him into a kind of hero. And if you go to creationist websites today, you can find that quite a few of them cite Bob Jastrow, which is a little too bad because if they actually thought seriously about his arguments, I mean, some of them are pretty interesting and not easily dismissed, in my view. So he was a kind of sophisticated religious thinker, is how I would put it. But nevertheless, you do see later creationists, and what happens is then the later creationists make common cause with some of the later climate change deniers. And you begin to see the same strategies and tactics. We don't really know, it isn't certain. Scientists are arguing. Here's a scientist who disagrees with evolution, that proves that it's unsettled. The cherry picking, how do you explain the eye, there's my eye. There's all this kind of weird gymnastics that take place. So yes, you do see connections, but they sort of grow over time in an interesting and somewhat different way.
Yet another book.
but not for me.
Last question.
I'm probably going to get into trouble for asking this question, but it wouldn't be the first time, so I'm ready for that. I'm a professor in the Department of Geography here at Western, and we do have a strong climate change denier in that department. We also have a very strong proponent, well, member of the UNFCCC board of Bain, so we have both sides.
That must be fun.
That leads to some interesting conversations. I guess the scary part for me is that the climate change denier is possibly our most charismatic and popular instructor, and convinces many of our students to his views. And I wondered if you had any advice how institutions, and academic institutions in particular, might respond, or does the principle of academic freedom simply outweigh that?
Yeah. I think that would be a great topic for another Rotman Institute seminar. No, seriously, I mean, that's an incredibly complicated issue. I think it's actually a really important one. I don't think that universities have ever really historically taken the position that academic freedom trumps all other considerations, and that anyone should be able to say anything in an academic environment under the guise of academic freedom. And I think the vast majority of history departments in America, for example, would not countenance a history faculty member who promoted Holocaust denial, right? So I do think that there's an interesting question about where you draw that line, and also how, as a department, you might respond, because you might decide that you respect his right to have his views and his right to express them to students, but you might also decide as a department that you might want to take steps to make it clear that that's a extreme minority opinion, and it's not the views of the vast majority of scientists who work on these questions. So that would be a short answer to a complex, difficult, and subtle problem. And I throw that one back over to the president.
Thank you so much. Thank you so much. It's my sad duty to bring this part of the conversation to an end, but not without first thanking Naomi Oreskes for outstanding conversation. Thank you. And I would also like to thank Paul Kennedy and Naomi Oreskes for their conversation. Once again, thank you so much for an outstanding job. We have a small token of recognition for Naomi and Paul, which I'll hand out, but I'm also here to say that the happy side of my task is to say that there is a reception to follow. It will be sticking around, and there can be lots of personal conversations about all the topics that we failed to talk about, and many of that we did talk about. So thank you once again for an outstanding event.